giving people a few extra minutes to come on. But so I want to thank everyone for joining us. My name is Karen Coyle, and I'll give you an idea of how this next hour is going to go. To begin with, you should know that we are recording, which means that we'll also be able to make it available in the Dublin Core YouTube account. And as we go along, if you have questions and want to put them into the chat, that would be very helpful. Now, this is an introduction to some work that we've been doing in Dublin Core on application profiles. Now, Dublin Core has been working on application profiles for a very long time, but this is the first time that we've attempted to create a vocabulary that can be used to create application profiles. It's an effort that we've been working on for probably a little over a year and a few months by now. And we feel like we're getting very close to what we could, put out as a beta solution. So our purpose here is to give people an idea of what we have done and to solicit questions from you, and also to solicit information from you in terms of how this fits into any work that you've been doing in creating metadata application profiles. Oh, there we go. It's been as I say, we've had a group working on this in the Dublin Core area. I'm Karen Coyle, I'm the chair. Tom Baker is representing the Dublin Core Metadata Initiative, and others are Phil Barker, John Huck, Ben Riesenberg, and Nishad. And Nishad is on here, and don't think I can pronounce your last name. I'm sorry, Nishad. But we've also had a lot of input from others through our mailing list and through GitHub issues. So this has been an effort that has involved quite a few people. I want to begin by talking about what our view is of a profile, because some people may have different ideas of what a profile is. So in the Dublin Core context, a profile is a definition of a particular metadata practice. And it's a practice, the profile shows what constraints there are. It constrains the structures, the properties, and the values that will be used in the metadata. In Dublin Core practice or community, a profile is always a reuse of vocabulary terms that have been previously defined. It does not itself define any new terms. There are a lot of reasons why one might create a profile. A profile has quite a few different purposes. One of the main purposes is that it helps document a community practice in metadata. And it defines it both for people, for humans, and for machines. The profile can also serve as input to data creation forms, helping the data creators to create metadata that conforms to whatever rules have been determined for that metadata. A profile should be able to translate to data validation and data validation methods. And if you are accessing data that exists, for example, in a database or out on the web, it can help you define what your selection is and what you wish to retrieve from those data sources. In particular, what we have tried to accomplish with this particular standard or practice or recommendation, however we want to call it, is we want to be able to define the basic structure of the metadata. We want to define the constraints on the elements of that metadata, and those include things like cardinality, meaning, what is optional, what is required, the data types of the elements of the metadata, and any constraints on the values. Because we want the profile to be usable also by human beings and to be able to express to human beings, that we want to provide readability of the profile, and that includes labels of terms and any notes that are needed. Now, I want to say that we have defined this particular beta instance with RDF metadata in mind, because that seemed to be one of the primary uses of profiles today. But what we hope that what we're doing is not limited to RDF metadata. So we've been trying to think about this both with RDF in mind, but also with a larger view of the metadata world. One of the issues that we have run into very much while we're working on this, and that will probably be, confusing for others as well, is that in developing this vocabulary, we have a meta problem. When you talk about profiles, you can be talking about really at least three different things. One of them being the vocabulary and structure for the profile. That is a vocabulary and structure for any profile. Then there's the profile itself that describes some metadata. And then there's the instance data that conforms to the profile. The vocabulary that we're working on, the tabular application profile vocabulary, only covers number one. So that's what we have been working to develop, a vocabulary for profiles. In this talk, I'm going to be showing you example profiles in order to illustrate what you can do with the TAP, with the Tabular Application Profile. I won't be showing you instance data. We are developing some examples with instance data that will be in our GitHub repository, but including instance data would have made this entire slideshow much more difficult and complicated. So we won't go there, but hopefully in the future, we'll be able to talk about that after people have kind of absorbed this first step of profile development. In keeping with the sort of general philosophy of Dublin Core, we have limited the TAP to 12 elements. So in a way, it's very simple, but we also feel that these 12 elements cover most of the basic needs for the creation of an application profile. I'm going to go through all of these so you don't need to memorize what's on this screen, but I just wanted to show you that it is a very small number. Those 12 elements, when used in a table format, and we are intending this to be compatible with a tabular format, they basically cover what you would consider to be the header row of a table or a spreadsheet. So this is the part of this practice that we are attempting to define. Now, why are we talking about a tabular format? When we began looking at this, it became, and we looked at a number of different application profiles that people had developed for their metadata, it became clear to us that one of the simpler cases, and also one of the most common cases, was that people create their profiles in spreadsheet programs, or if in documents, as tables. And so we felt that the tabular format would be the most common format that people beginning to create their application profiles would relate to. It also is quite simple. The software is readily available. And we are, again, as often in Dublin Core, we're looking to create a sort of a core, not universal, but very commonly used set of elements for the application profile. Now I want to go through the various the various elements of the application profile. Out of all of them, the only one that is required is to have a property identifier. Property identifier meaning things like, Dublin Core creator, title, date, publisher. You could create an entire application profile only with properties, a list of properties that you're going to use in your metadata. However, a simple list of properties probably is not really enough. In most cases, you will want to add a data type. So you want to say which properties are going to be strings, which properties are going to be year, date, year, etc. Or if you could have numeric, you could properties that are integer, etc. So usually after you define what you want your properties to be, you want to say what type they are. We also wanted to make it possible for people to include eye-readable labels and any notes that are needed. So, and the notes area is quite open. It can give instructions, it can give explanations, anything that you need. Again, this is something that we saw was very commonly included in application profiles. It's also quite common to say which of your properties are going to be mandatory and which will be repeatable. So we have those included as elements. In many cases in your metadata, you're talking about more than one thing. The simplest metadata, as I said, may be just a list of properties, but oftentimes you want to talk about multiple things that relate to each other in your metadata. And common example is that you can have a book thing, and that book thing has a creator, and the creator is of a type person. And that is because you want to say many things. Here we're showing only two, but you want to say things about that person. So we're calling these shapes, these groups of these groups of properties and constraints on the properties that relate to one type of thing in your metadata. And so here you can see that this is a book shape. And each shape consists of a group of what we're calling statement constraints. That is the property ID label, whether it's mandatory, repeatable, the type. And all of those are gathered together with the same shape identifier. So these are the statement constraints that are within, this is an example of one statement constraint that is within a shape. So we have the book shape, we have the person shape, and then the question is how do we make the connection between these? And it's done through an element called value shape. So this is when the value of a property, rather than being a string or an integer, is another shape. And so the value shape column will have the same exact contents as the shape ID. Now, because we've thought about this in terms of RDF, there were some particular elements that we wanted to add in order to accommodate RDF and being very careful to be compatible with the RDF standard. RDF has node types, and those are B nodes, literals, and IRIs. And there are times when you want to define what your node type is for whatever purpose in your metadata, and especially for validation. In RDF, the value types are only defined for literal nodes. And so in our table, you can define your value node type, and for all of the literals, you would define a value data type. And in the RDF standard, all of the value data types, all of the literal value types are taken from the XML schema standard. And so that's what we've included here. Now, beyond saying that something is a string or an integer or a year, you may want to say more about it. So, for example, you may want to say that your subject string is going to be always be the word history. And given that this may be used in RDF, if you want to give the class type for a shape, then you would give that as a value constraint. So you would say that the type, the author type, for all things that are authors, the type is, for example, the class FOF person. Now, value constraints get to be a bit complicated, and we've worked on this quite a bit and have tried to limit ourselves to a few what we consider to be the most common value constraint types, although in the end, we may end up adding some more. It's hard to know. But this is where we are with this today. Let's say that you have an element such as subject and you want to use terms from a particular identified thesaurus or term list. Assuming that those, in order to refer to them, they would need to be IRIs or URIs. So we've created a value constraint type called URI stem, in which you would give the URI for the list, and then what would be valid would be any element from that list. There's also a possibility that you may want to use patterns like regex patterns, and that would be applied to whatever is in the value. Another very common thing is to have a small list of valid elements. So for example, a pick list of colors. You could have a small pick list of, let's say if you're doing an educational institution, it could be a list of departments. All of these are, we consider a value constraint type, and then you can do your lists of things that would then all be valid values for that particular element. And again, given that we're thinking that these might be used within RDF, one very common constraint that one might use would be to use the language tags. And so we added a value constraint type for that. One of the things we'd be very interested to hear from any of you is what other types of rules you have for the values in your metadata that we haven't included here, so that we could consider whether or not we feel that we can add those. We also spent quite a bit of time trying to figure out how to handle multiple values in a table cell. So because this is a tabular format, some of the sort of more complicated elements that you might want to do in your metadata may not fit in. We realize that with a tabular format, there are limitations. But we do know that very often it is going to be necessary, and as you saw in the previous slide with the pick list, it's going to be necessary to provide more than one value. So we haven't really come up with strict rules for this, but because we're assuming that the tabular format will most likely be, for example, exported from a spreadsheet in a comma separated value CSV format, that we have made it so that the most common usage here is to use commas, but you could also use pipes. You could use anything that you expect people who are downstream and are looking at your profile will understand. We definitely do want it to be possible to handle multiple values in a cell. In this case, however, all instances of multiple values are OR functions. So it is red or blue or green for a particular value, or it is, ing, fren, span for the language values. We're using OR here because, and we have not done the and or not values. Those are a bit more difficult. We couldn't think of a good way to combine ors and ands and nots. At the moment, we are putting this to be out of scope, but we would like to eventually be able to accommodate both and, or, and not. So at the moment, everything is sort of a list of choices when there's more than one value in a cell. With the Boolean values, so as you saw for like mandatory and repeatable, with which both are Boolean, again, looking at the XML schema standard, which is what RDF uses and what is also used in a number of other data formats, the two possible Boolean values are to use true and false or 1 and 0. Other uses, of course, are possible. Yes, no, whatever. But if you use anything beyond the standard values, then you have to have a way to communicate that to anyone making use of your profile. Now, you saw in the examples that I gave that we had things like DC and we had FOF, we had RDF. In general, in most programming today, including the full URL is just difficult. It's hard to read. It's hard to type correctly. In a tabular format, it would make the tables very long. So we're assuming that people are going to want to use sort of a standard prefix that takes the place of the namespace in the documents that most people encounter. Unfortunately, it was not possible to find a way to place this information in the same table that the TAP uses. This has to do with how tables and comma delimited, mainly comma separated tables, the rules for those. So we have assumed that the information about the prefixes and the namespaces would have to go into a separate file. We think it's not difficult to come up with a format for this file. And the reason why it is still unresolved is that we need to discuss how the namespace file and the profile file will be kept together so that they travel together and can be used together. So that is something that hopefully will resolve fairly shortly as the group continues to meet. We also have not quite resolved how to define the TAP as a vocabulary. We've created a file that gives a very simple RDF definition for the vocabulary. What is holding us back still is that we're waiting to develop or to discover what namespace we want to put this under. Dublin Core has its own namespaces. We may use one that already exists. We may develop one for this particular vocabulary. One of the things that is holding us back a bit is that Dublin Core makes use of the perl.org, the Perl server, and that has been not very stable lately. But we are assuming that there will be a defined vocabulary, and therefore each of the elements in TAP will have a uniform identifier. There are things that we haven't gotten to yet, but we would like to. And one of the key ones is we want to find a way that people can internationalize the table, that they can internationalize the tabular format, so that people are not constrained to use the sort of pseudo English language terms that we've developed. And we would like very much to be able to do this. It probably requires there to be some information in addition to the the vocabulary itself and to the table itself, so that these other terms, these synonyms, can be carried with the table, and that it can all be connected back to the base vocabulary. So things that are out of scope at the moment, one being more complex relationships between properties or shapes. So if you want to say, in my metadata, I can use either FOF name or FOF family name and FOF given name, or if you want to say it's mandatory that I have either a professor shape or a TA shape for each course, etc. These things are all very difficult to do in a tabular format, because in a table there aren't really relationships between the rows in the table. So we're going to continue to look at those. We haven't decided how or if we can have a profile that uses what in a spreadsheet program would be multiple sheets. In other words, you would have different files of data that would have to relate to each other in some way. In RDF, there's the concept of sort of an open world and a closed world. We have looked at this. We have not come to a conclusion about it. We definitely want to hear what type of rules people are using in their own metadata for open and closed. And if we can gather some examples, it may help us cover this. We've talked about it, but we didn't come up with a nice, neat solution. So I want to give you, these are the some of the resources. Everything is on GitHub under Dublin Core Metadata Initiative, DC TAP. What we have there, we have a primer, we have the vocabulary, and a document that defines each of the vocabulary terms. We have examples, and we have the vocabulary itself in RDF. If you interact in GitHub, we would love for you to respond to issues or open issues, or let us know what you're thinking. If you go to the main GitHub repository link, it tells you how to join the mailing list. We would also like to receive any data that you have that can be profiled, or profiles that you have that we could see how they relate, how they can sync up with this vocabulary. So now I would like to know if folks have particular questions relating to what we've said here. And Tom, if you can look and see if any questions came in, we might.
Yeah, I'm looking at the chat channel, and not seeing any yet.
Okay. So if you do have questions, if you could put them into the chat. You can also contact any of us afterward. You can send in questions to the mailing list. You do have to subscribe to the mailing list to send in questions. But as I'm the administrator on the mailing list, I'll see if any come through.
Okay, here's a question. Why do you use the term shape?
Tom, I should let you answer that one.
Sure, I can.
You were the main person to.
Yeah. Um, well, there's a number of standards now, shape expressions language and shackle, that use the word shape. Um, this is to avoid confusion with things that it looks a bit like a class, but class in RDF is a much different thing. A shape is it's like a template for against which you can compare the actual data that you have. So it's really a construct that is intended to describe the content of your metadata and to provide a basis for validation. And it has become, it has become more um, commonly used in the past 3 or 4 years because of SHEX, Shape Expressions Language, and Shackle, which is a W3C standard. Okay, so I see more questions coming in. We can see the DC tap as formalizing the structure. Can we see the DC tap as formalizing the structure of a data model in the sense that all properties will have to conform to the 12 elements, which will allow for easy exchange of data and validation?
I can take that. Yes, basically that is the intention of the DC tap. It's the reason why we have done things like leaned on standards like XML schema for example, for the Boolean values and the string values. We are hoping that most of what is in a profile will be a well-known practice that others can understand. At the same time, we have to say that the tabular format means that this will work for a certain number of relatively simple profiles, but it will have to be extended in order to, or if it gets to that point, to cover a wider world of profiles, and therefore could be seen as being a generalized profile language.
Okay, we have another question here. What's the meaning of value shape? Why is the value shape of book person? I can answer that if you'd like.
Yeah, go ahead.
So we're looking at this. It's still on the screen, right?
Yeah.
Yeah. So in the far right corner, you see value shape as person. Why is that? It's because a book if you look at that line, if you look at that row, a book has a creator, and the creator is something that conforms to the shape person. So you can have these dependencies between shapes where you're expecting metadata about a book to have a a creator, and you're expecting the that creator node to be the to conform to the person shape. So you're describing essentially a dependency between the book shape and the person shape.
Yeah, I think if for those people who are familiar with XML and XML schema, you would see these as being nested in XML, whereas in RDF, they these are connected by nodes. So you have the book node that connects to the person node. If you think in terms of, for example, relational databases, book and person would be tables that connect to each other. It's just that in this tabular format, it's kind of awkward to show that type of dependency.
Okay, we have a question. Could you explain more about the relationship and interaction between DCTAP and schema.org? I can take that if you'd like.
Sure, go ahead.
So, so when we say RDF data, I think we need to realize that RDF is also basically the model underlying schema.org. It's the model underlying Wikidata. Um, the Wikidata and schema.org models are different flavors, if you will, of RDF, but um, schema.org defines schemas that are quite general, and that's by design. It's designed that way, and so you could use the TAP model to make an application profile based on schema.org and express more constraints about that model, things like cardinality, that sort of thing.
And I should note, because I thought you might do this, but you didn't, which is that Tom has already created a way to go from DCTAP to the Wikidata schemas. So this is quite compatible with a number of other, with a number of RDF vocabularies that you might want to use, but not use the entire vocabulary. You would prefer to develop a profile of just the parts of that vocabulary that you wish to use.
Okay, we have another question. Can we take BibFrame application profile encoding with JSON as a DC tap?
I have done some work on that. There are some things in the BibFrame profiles that go beyond what we have here, but there is in the examples, I believe, no, there isn't. That was RDA. Yeah, so sorry, I'm confusing things, but this probably isn't as sophisticated as the BibFrame profiles, for example, Sinopia. So probably now we should turn to Tom is going to talk to us about some of the programming work that is happening to try to show how this DC tap can actually be used to develop validation, automated validation of data.
Okay, can you see my screen?
Yes, I see your screen.
Okay. So I'm going to talk about how DC tap relates to the notion of data validation. And, oops. I wanted to start by saying 祝大家牛年快乐. So Happy New Year.
Happy New Year.
So let's take some data. This is based on the example that uh, Karen showed. So you have a book, it has a date, it has a title, it has a creator, and that creator has a name. Oops, how do I advance the... So this is the data viewed as a graph. So a data describes entities. So you have a book and a person, and I've highlighted those in the data example in the lower right. And it describes those entities with statements. So with property value pairs. So the title is Moby Dick, and the creator is an entity that has a name. An application profile, what it does is it defines constraints on those statements. So if these are statements, these are statement constraints. And so a statement constraint says that the DC title property must be used, but must not be repeated, and that the value must be a literal. This says that the date must conform to the XML schema notion of a year. This says that the creator is something that is described by a person shape. So this gets back to the question that was asked just 10 minutes ago about the value shape person for a book. And and here is a FOF name, the value of which must be a literal. So this is all done in the context of shapes. And as Karen said, a shape is a group of statement constraints that share a common subject node. So in this case, it is the book node that has a date and a creator and a title. And here is the person shape with just one property. So how do these two relate? So you take the data and you validate it against the application profile. So you're comparing the two, and you're seeing that yes, FOF name is used, and yes, it's used with a literal value. So the statement constraint passes validation. And because that's the only property, it also passes the person shape. The person shape is also valid. Then you have, um, yes, the DC title, there is a DC title. It's used once with a literal value. So the statement constraint passes. And same as the date. The date is used with a correct value, so the statement constraint passes. Um, this statement constraint DC creator is used with a person node, and the person node has to conform to the person shape. And we saw above that the person shape passes. So the book shape also passes, and all of the data passes. So here's an example down below of a CSV file. It's just the way that it looks on the disk. But this is, well, this is essentially the same example that Karen was showing. This is what the profile that I have just illustrated looks like when you put it into an Excel spreadsheet. Okay, I wanted to talk briefly about a software project that we have, and um, in fact, is more than one software project around the DC tap model. Um, this one is about transforming a file in the tap format from CSV into SHEX, shape expressions language. And why would one do that? Because shape expressions language is a full validation language. If you translate a spreadsheet into SHEX, you can use the SHEX validation engine to compare your instance data with your SHEX schema and tell you if there are any constraint violations. So you can do that for quality control, or you can do um, you can use a SHEX for any of the other functions that um, Karen put up in one of her slides. For example, for selecting incoming data that you want to um, uh, make a selection out of data that you are harvesting somewhere, that sort of thing. There are many uses for profiles, and SHEX can be used for those, not just for validation. So the idea is that you can point the program, that's a command line up at the top, point the program at a CSV and see what it looks like. So you're taking this down at the bottom. The CSV on the disk is completely unreadable if you just look at it, because your eye cannot parse all of that. It turns it into a nice display, so you can debug your CSV. Although I should say that most people using the TAP model would use it in a spreadsheet application like Excel. Um, and so you can then use that to generate um, a SHEX schema. So this is a SHEX schema expressed as JSON. There is also a compact syntax which which is not yet supported. I should say that this program is very much work in progress. It it needs to be improved, and we've been working on the TAP specification, and so the program itself does not support everything yet, but this is the idea, and where we want to take this as a next step is to have a um, to be able to point the program at a CSV file and have it generate a Schex schema using the compact syntax of Schex, which is easier to read. And in principle, um, it's because we're using Schex libraries, Python libraries in the program, and those Python libraries support validation. In principle, it might be possible to then to just point the program at some data and have it produce a validation result. So to conclude, I want to just review some of the main constraints. Um, some of the main terms that we use to talk about the difference between instance data and application profiles. So in instance data, you have entities, which are the things that are described in instance data. And they correspond in an application profile to shapes. Shapes match data for describing a given entity. In instance data, you have statements. So you have property value pairs describing entities. And in the application profile, you have statement constraints, which characterize different types of statement, depending on what properties they use and what constraints. You have, in instance data, you have properties, which are attributes of entities. And in the application profile, you have property constraints, which match properties in data. And finally, in instance data, you have values, which are the contents of the attributes of entities. And in an application profile, you have value constraints, which match characteristics of those values. So we admit that it's a bit confusing too, but uh, we are trying very hard to use a consistent language to talk about these things, because it is easy to get confused between the language of instance data and the language of the application profile. And they're two different things that have a specific relationship to each other. The application profile is about the instance data, and it's compared against the instance data in order to yield a result, for example, um, to yield a validation result. So that's the end uh, of my presentation, and
Okay,
I
thank
will.
you, Tom. We did get one question coming in, which was asking whether the recommended encoding format for DC tap is Schex. And I think we can say that any validation should work, either Schex or Shackle. Obviously, you know, this particular program is being done in Schex to go to Schex validation. shackle validation. It should also be possible to use, for example, XML schema. So that we feel that the elements that we've defined are general enough that most validation or schema languages should be able to be used once the profile is developed.
Yeah. JSON schema is another possibility.
Right.
Yeah.
So we have gotten to the top of the hour. If there are other questions, people should shout them out in the chat, please. And we can, Tom and I can hang out here for a little bit to see if there are other questions. Again, we'll make this recording available. We'll make the slides available. They'll all be on GitHub, and we'll try to make sure that the folks who spread around our call for this meeting will be available. Will also let you know when the both the video and the slides are available. Because and all of those, people are free to pass those around or spread them around as they wish. Because we really do want to get information about this out as far as possible. We're hoping that we will be producing more documentation. We'd like to be, present this at conferences, although, this being the the time that it is, it's a little bit harder to get opportunities. It definitely almost no face-to-face opportunities, but to get this information out to folks.
Looks like we have one final comment that one participant is using XSD and JSON to define the constraints of properties and values. So it would be great if they could get in touch with us, and we'd be interested to see if the TAP model can also help in that situation as well.
Yes, because one of the things that I think will be very helpful for us will be to look at a number of different existing profiles and to see to what extent this model satisfies the needs of those, and also to understand exactly where it is that what the limitations are of this particular approach, of this tabular approach, because we may have an opportunity to go beyond the tabular approach, and especially after seeing a number of different profiles and their functionality, to understand which functionality we aren't yet addressing. Okay, well, if those are the questions, and again, you're welcome to get in touch with any of us to participate at the Dublin Core GitHub site, or to join the mailing list. The mailing list does not get a large number of mails to it, so that it isn't overwhelming, but it is a place where you can ask more questions if you'd like. Okay, well, thank you all for joining us, and we hope to hear from you and to be more in contact with you in the future. Thank you.
Thank you. Will you make the slides and the recording available, Tom?
Um,
Or slide,
yes,
maybe
yes,
slide.
yes, yes.
Yeah, yeah, we'll put the slides online, and then the recording goes to will go to the Dublin Core YouTube channel.
Cui Dren, yes, please do send me your paper.
Yeah, maybe they can test in different language.
It would be great to get, translations of these once we get to the point
Yeah.
that we can, that we feel like the text is fairly stable. And I don't know if anyone has the ability to
Maybe
add titles to
maybe,
the video.
I see Wei Fan, Fan Wei, who's here at the Sichuan University. He was the one translated the scars and and translated the linked data competency index.
Okay, great.
So
That would be
maybe,
wonderful.
so Wei Fan
That'd be
maybe,
great.
yeah, would be.
Wonderful. Yeah.
Yeah. Although we want to wait until, we feel it, we don't want someone to have to translate and retranslate. So
Right.
we'll let you know when we feel like the document is stable enough. Yeah. Because that would be wonderful.
Okay.
Karen, should I close the meeting or?
I think so. Yeah. I think we're at that point.
Okay. Thank
Great.
you all.
Thank you.
Bye, Marcia.